All right, good afternoon, everyone. I hope I can be there, but due to the visa issues, I cannot. So this research is about RAG enhanced safety information retrieval for construction. We collaborated from both like University of Washington Construction Management Department and Civil Engineering Department in University of Alberta, and also our industry partner PCL Construction. Thanks so much for Brian. Our title here again, it's more about like the integration of a large language model and the RAG system itself. So let's just start. So the first part is the table of contents. Like I would just do a brief introduction and what's the motivation behind it, and what's the literature review and research gap, and system architecture, and what's our data processing pipeline, and our model selection and fine tuning, why we select this model, and our validation result, and some discussion. All right. So the current state of construction safety. So the construction remained one of the most hazardous like industry globally, as we know. Like we got persistent workplace accident despite we got so many like technological advancement like robotic and VR AR stuff. We also got critical safety information scattered across numerous documents. Every time we ask a superintendent to do safety inspection, it's always like cost too much time. And so here we generate the key challenges, like we got traditional document system proof inefficient, and we got the manual search are very time consuming and error prone. And we got a dynamic nature of construction operation require quick access, like of course, a natural language one, right? And we got risk of incomplete information retrieval. So specifically here, we got the technical challenge here. We got the scale of documentation challenge, like just like we said, if we ask the superintendent to do they wanted to look up into those kind of safety codes, they're going to spend tons of hours to just simply find the protocol. And in case of that, we ask the PCL construction, they provide us their almost 1,300 pages of safety protocol, and we ask them to provide like more than 300,000 words across multiple document types as our base for our AI model training. And it includes like 37 different documents, including manual forms and specifications. So our approach across this is actually do a model itself, like with retrieval-augmented generation. So it's gonna automatically accurate response to safety query. If you ask them like what's the crane code in Alberta, it's gonna quickly answer you. And we also got the natural language interaction, so we don't have to like use specific keyword. And we also got the construction specific understanding for the AI model itself. So we did a lot of literature review and research gaps. So from the previous slide, we showed the industry challenge, and we also got the technical challenge here, like from the literature review. Previously, the NLP research in construction is pretty scattered between natural language understanding and natural language generation. So this large language model is truly an opportunity for us to combine those two. So here is our data processing pipeline and our system architecture. So the first part is the system architecture. We got our pre-processed data from the PDFs, those kind of documents provided by PCL, and we put them into an embedding model. We currently use a BGE large model, and we also use human cross-validation to create the vector database. That includes part of the chunking techniques. And that vector database is going to interact with our fine-tuned large language model, which is we didn't use a commercial model. We used our own model, the Llama 3 8 billion. We downloaded from Mehta and we fine-tuned it. And the model itself is going to do the similarity search from the vector database and give the answer to the model itself, then generate the responses. So to create such structured data for us to do the embedding, we need to do data processing from the PDF document. The first part is to use the unstructured package to basically translate the unstructured data to table, image, and text. And if we wanted to use table and image, we are going to call the GPT-4 API, Vision API, to do the visual translation to translate those table and image to the JSON. And for the text, we are just going to directly use the GPT-4 to generate summaries and understanding to JSON file. And after that, we can get the structured data. So we selected Llama 3 8 billion model as our base model because, like, first thing first, we wanted to run that in a commercial computer. So basically our own PC. And also, like, because we picked that through other models. The Llama 3 8 billion got the highest score in the MMLU. That's a multitasking benchmark for most of the large language models. And after the training process, we also got the fine tuning. We actually transferred the data itself into more than 10,000 question answer pairs to basically use the fine tuning technology to leverage the construction knowledge and the large language model's capability. So our result here actually shows the rogue metric comparing with the base model. The base model is Llama 8 billion without fine tuning and RAG. So we ask several questions to basically test its understanding about construction safety code. And apparently our model performs way better than the base model because the base model does have general knowledge but doesn't have specific construction knowledge on safety. So we use rogue 1, rogue 2, and rogue L and cosine similarity to do the test. And actually, those advanced scores are indicates very balanced precision recall rates here. And we also do the qualitative evaluation. So we use the channel to create a front end, like those kind of user surface here. So for example, if we ask them what are the steps for crisis response, and here at the right, you can see our journey chatbot showed a very specific answer, 1 to 7 different steps. But if we ask the general model, its generation is going to be more vague, but a little bit mouthful here. And the final discussion conclusion, we successfully implement the RAG retrieval-augmented generation for construction safety, and we basically seamless integration of like retrieval and natural language interaction. And we also successfully to find out that we can embed domain-specific knowledge with fine-tuning and the vector database itself. And since we are using those kind of small model, like we can basically embed the knowledge in local, so we don't have to worry about the data privacy issue. But the limitation here also, we got some limitation here. The first thing is like we can only do process on the English documentation right now because the 8 billion model doesn't cannot do like Duolingo stuff right now. And we focus on the retrieval, not content creation. So in the future, might be those kind of agentic work might be better because we are also working on that. And we also wanted more like field validation from the PCL and if possible, like the people in the room right here. So future work, we can have real-time site deployment. And if possible, we can have the BIM system integration here. All right, that's all. So